Imagine the Earth with no atmosphere.
Whoa. One of the last things we want to have happen is for our atmosphere to disappear. If our atmosphere were to go away, well, the oceans would evaporate, and that would be the end of life on the planet for sure.
Or a place with greenhouse gases so thick no heat could escape. With a surface so hot it would melt lead. Or a planet with a massive storm the size of the entire Earth.
The Great Red Spot is an anticyclonic storm. As for what exactly causes these winds, that is a great mystery.
All of these hostile places and others exist in our solar system. Join us as we visit them on this extreme episode of Exploration Outer Space. Hi, I'm Emily Calandrelli, and welcome. On this episode of Exploration Outer Space, we're exploring extremes of our solar system. And we're starting with the third planet from the sun, Earth. Earth is a planet of extremes. From its superheated core that produces burning lava, to tectonics that create earthquakes, to weather thrashing our lands and seas, Earth experiences the devastating forces of nature every day. They shape the planet. There are, however, even more dangerous forces from space, and they too could shape the Earth, but in ways that could be catastrophic. There is solar wind, which could strip away the ozone layer, which protects us from ultraviolet radiation.
If ultraviolet radiation were allowed down to the surface, sunburn would be the least of your worries. You would talk about various types of cancers, DNA damage and possible errors within a genetic code, and unmitigated cell growth.
There are also meteors that could have devastating impacts on the surface. The Earth's magnetic field and atmosphere protect against these outside forces of nature. The moon shows what a world without either of these protections would be like. With no atmosphere, sunlight doesn't scatter. The moon's sky is always black.
When the first astronauts stepped out onto the surface of the moon, one of them, Buzz Aldrin, remarked about what the surface of the moon appeared like. He said it was magnificent desolation. Part of the reason why he said that is because of the stark difference in the brightness of the surface of the moon versus the pitch black of the sky. Now on Earth, our sky looks a beautiful blue because of the way the gases interact with sunlight to make the sky look this beautiful blue. On the moon, where there is no atmosphere, you get none of that absorption or scattering of light, so the sky looks black.
Without an atmosphere, Earth's fate would be similar, dark and desolate. Our planet might end up looking something like this. If we were to lose our atmosphere, our oceans would vanish.
If our atmosphere were to disappear, we'd lose that atmospheric pressure. That means the boiling point of water would drop dramatically. So all of the water on the planet would essentially boil away into space, and we'd be left with no moisture here on the planet at all.
Without an atmosphere, there would be no oxygen and therefore no chance of survival. Earth without its atmosphere would be dry, dark, scarred, silent, and dead. Could it happen?
The Earth will eventually lose its atmosphere. It's just a matter of time, but it's not going to happen for a long while. Eventually, the sun will expand into a red giant, and when that happens, it will blow away all of the Earth's atmosphere, essentially. By that point, we will be long gone. We will either have advanced to the point where we've left on our own accord, or we'll be gone in another fashion.
Fortunately, so far, we have mostly avoided the lethal forces of space, unlike our planetary neighbors. We're about to set out on a dangerous journey through our solar system.
What's going on in the atmosphere there is called the greenhouse effect, and the temperature can be upwards of 900 degrees Fahrenheit with no problem at all.
Welcome back. We're about to take a journey through our solar system, making a few stops along the way. We'll survive our virtual journey, but no human being could withstand the extreme conditions of the places we're about to visit. Buckle up and let the journey begin.
3, 2, 1, 0.
First stop, Mercury, closest planet to the Sun. Much of what we know about Mercury comes from the Messenger spacecraft launched in 2010.
NASA's Messenger spacecraft orbited Mercury for over 4 years, carrying out a highly detailed map of Mercury's surface that we still use to this day.
Once we arrive there, we'll find a barren, lifeless planet that looks like our moon. Giant craters are everywhere because there is no atmosphere. There is no rain here, and there is no wind. Mercury does have a magnetic field, but it's no match for the Sun, which looms menacingly large in the sky. And it brings heat, searing, blistering, life-incinerating heat. The temperature on the ground is 450 degrees Celsius. Take your oven's highest temperature, almost double it, and try living in it. Welcome to Mercury. But there is a surprising irony about this forsaken place.
Closest planet to the Sun, but once you rotate away from the Sun, you go into darkness on the nighttime side, drops all the way down to as low as negative 300 degrees Fahrenheit, and you'll do it pretty rapidly.
If Mercury is unbearable, our next stop is even more so. From above it, you're greeted by a strange-looking atmosphere that is orange and red. Prepare for Venus. Something crazy happened to this planet. A few billion years ago, it had an ocean. It could even be thought of as Earth's twin. Now, it's Earth's evil twin. This is a diabolically hellish planet. Let us count the ways. The clouds. They consist of sulfuric acid. Not only would they eat you alive, they would smell like rotten eggs while doing it.
Venus actually has a lot of volcanoes, somewhere in the neighborhood of 1,600 volcanoes, and some of them are really quite active. So when the sulfur from the volcanoes mixes with the atmosphere, it creates the sulfuric acid that rains down onto the planet. Not a very pleasant place to be.
Venus has a super thick atmosphere, about 90 times more massive than Earth's atmosphere. When we talk about climate change on Earth, we talk about greenhouse gases like carbon dioxide being trapped in the atmosphere. Venus's atmosphere is 96% carbon dioxide, which means it experiences a runaway greenhouse effect. The heat has a one-way ticket to the planet. It can get in, but can't get out.
It's like having a blanket surrounding the planet. The heat stays within the atmosphere, within that blanket of clouds, and the temperature of Venus can be upwards of 900 degrees Fahrenheit with no problem at all.
For this reason, Venus is the hottest planet in our solar system. It's been nearly impossible to get decent pictures from Venus's surface. Most any substance will melt, including lead. And for good measure, the pressure on the surface is rather daunting. It would feel like your body is nearly 1 kilometer underwater. Upon exiting your spacecraft, you would be crushed by a force equivalent to 80 tons, while simultaneously being incinerated. So in short, this is not a place you'd want to visit. Yeah, it's time to get out of here. On to our next extreme destination.
The lunar South Pole is certainly the coldest place on the moon, and it might even be the coldest place in the solar system entirely.
Hi, I'm Emily Calandrelli, and this is Exploration Outer Space. We're on a journey to the extremes of our solar system, just having visited Mercury, then Venus. Now, it's a long trip from Venus to Mars. Along the way, we should refuel. In the not-too-distant future, we will have human settlements on the moon. One primary purpose will be to extract fuel. What, you say? There is no fuel on the moon?
Recently, we discovered that there are actually some large inventories of water trapped and frozen within the moon itself. That can be broken down into its hydrogen and its oxygen, which can then be liquefied down into rocket fuel.
One NASA estimate suggests that there may be 600 million metric tons of lunar ice to harvest beneath the surface. But don't stray too far from the lunar base. Our smiley face crescent moon is not very hospitable to visitors.
The lunar South Pole is certainly the coldest place on the moon, and it might even be the coldest place in the solar system entirely. The tall crater walls prevent sunlight from getting into those craters, and so those places at the lunar South Pole stay really, really, really cold. In fact, the temperature there seems to be minus 400 degrees Fahrenheit. That's colder than Pluto, 3.6 billion miles out away from the sun.
Poor little Pluto. First, we redesignate it as a dwarf planet, then we discover it's not even the coldest place in the solar system. Turns out, our moon is. Which is a really good reason to move on after refueling. Next destination, Mars. Of all the places in our solar system, the Martian climate is the most similar to Earth's. At the equator, it is a positively pleasant 21 degrees Celsius during a sunny summer day. But don't be fooled. Life on Mars is no picnic. Its atmosphere is very thin, which means dangerous solar radiation reaches the surface.
The Martian atmosphere is over 100 times less dense than the Earth's atmosphere. It's so thin that there's increased radiation right down to the surface level. Radiation on the Martian surface is around 80 times what we experience here on Earth. So prolonged, chronic exposure that is a guaranteed cancer risk.
In order to survive, humans may need to live underground, perhaps in lava tunnels forged from previously active shield volcanoes. The largest one being Olympus Mons, as wide as Arizona and 25 kilometers high. It is absolutely humongous, perhaps the largest in the entire solar system. We humans could surface to plant our crops and happily hop around in the 5/8 gravity. The downside is that our bones would become weaker and more brittle from prolonged stays. The upside is we'd get taller since the gravity is weaker. Not an ideal place to call home. Cancer, brittle bones, and temperatures that swing wildly in and out of the sunlight. Ever wonder what would happen if you were exposed to the vacuum of space?
Your body will swell up because water vapor will start to build up in your soft tissues.
Continuing our journey from Mars, traveling away from the sun, we encounter a giant. That giant is Jupiter. Jupiter has been called a failed star. Like other stars, it's made up of mostly hydrogen and helium, but it's not quite massive enough to begin thermonuclear reactions in its core to turn itself into a star. If it were about 80 times more massive, it might have become a star. But even without that solar title, its immense volume could hold more than 1,300 Earths. Picture a grape on a basketball. That's how Earth would look on Jupiter. This giant planet is like a miniature solar system with 79 known moons. One of them, Europa, is thought to be a place where life could flourish.
Europa is essentially, when you look at it, it's an ice ball. It's covered with either an incredibly thick sheet of ice or a relatively thin sheet of ice. What we believe is that at least in some amount, it's either an entire global ocean underneath that ice sheet, or at least pockets of water underneath that ice sheet. And that makes it one of the best targets in the solar system to look for life outside of the Earth.
Jupiter is obviously no run-of-the-mill planet. Forget landing our virtual spacecraft here. That's because Jupiter is made mostly of swirling gases and liquids, so where would we land? The extreme pressures and temperatures deep inside the planet would crush, melt, and vaporize the spacecraft as it descended deeper into the planet. The most iconic feature of Jupiter is its so-called red spot. The red spot is a massive storm larger than the Earth. Think about that. A steadily rotating 539 kilometers per hour windstorm, bigger than the size of our entire planet. And it's existed for at least 150 years.
To us, it looks like it's a gigantic hurricane, but there's no ocean beneath it, there's no atmosphere above it, so how does it keep moving? Well, there's a jet stream that seems to travel north of it in one direction and a jet stream south of it traveling in a different direction, and that seems to keep this circulating.
Telescopes have been observing changes in the red spot, but no one can be certain if this heralds the beginning or the end of this age-old storm. One thing is certain: planet Jupiter is about as extreme and hostile to life as can be imagined, which is as good as any reason to begin our journey back home. In between Jupiter and Mars lies the asteroid belt. Most astronomers believe the asteroid belt is rubble that Jupiter's gravity prevented from coalescing into a planet. It comprises an estimated 1 to 2 million asteroids, which vary widely in size. If one of them clipped our spacecraft, that's big trouble. Because in all this talk about extremes, we've ignored the one most prevalent on our journey: the vacuum of space. First, some misconceptions. Exposure to the vacuum of space would not cause humans to blow up or freeze. Here's what would likely happen.
Now, because there's clearly no air in space, it's a vacuum, your body will quickly lose whatever oxygen store it had. So your blood will deoxygenate, and that means that your different organs will deoxygenate. Your brain will lose its oxygen, so you'll lose consciousness pretty quickly. Your body will swell up because water vapor will start to build up in your soft tissues, but you'll stay together.
So on our way back to Earth, best to steer clear of any dangers. The 627 million kilometer journey from the asteroid belt to home is a dark and lonely one. So the sight of Mother Earth with its brilliant and beautiful colors is most welcome. Upon re-entering Earth's atmosphere, be prepared for a fiery light show created by pressure waves and friction. And finally, we land in the ocean, home to dangerous waters and predatory animals, all which seem positively tame as compared to the extremes of our solar system. As we've seen on our journey, the other planets in our solar system are full of extremes. Freezing, burning, swirling, toxic. Human ingenuity cannot tame them. Right now, the Moon and Mars are the only candidates for human settlements, but it's far from safe. There is only one planet we can exert some measure of control over. Buckminster Fuller, a 20th century inventor and visionary, coined the phrase spaceship Earth, implying that we are all passengers on Earth's journey through space. We may not be able to pilot our planet as it soars through space at 108,000 kilometers per hour, but we can protect it, especially its fragile atmosphere.
Astronauts looking down on our planet from space have an extraordinary view of our planet, a unique view of our planet. This experience that they all have, they call this the overview effect. From their perspective view, they can see how thin the Earth's atmosphere is, and this reminds them of how fragile the Earth's atmosphere is and how important it is for us to take the best care we can, because that's all that's there protecting the Earth.
That thin blue line is what separates us from the nightmarish conditions of space. It's what separates us from our evil twin, Venus, with its superheated atmosphere fueled by greenhouse gases that poisoned it. Space exploration is vitally important, and every planet in our solar system is unique and extreme in its own way. But best to remember the famous words of Dorothy in The Wizard of Oz. There's no place like home. I'm Emily Calandrelli, and we'll see you next time on Exploration Outer Space.